Hi, this is Richard C. I'm answering a question submitted by a student who's probably taking pre-calculus or algebra 2. And this question has to do with um, hyperbola. So I got about halfway through the problem and then had some technical difficulties on my end. And then so I'm resuming it here. But let's start at the beginning. We have two vertices at -1, -3. So here's the first vertex, -1, -3. Here's the other vertex at 3, -3. And the first thing to do, in my opinion, is to draw a quick sketch of the hyperbola. You can see it's going to be horizontal. And the foci are also mapped, graphed here, -3, -3, and then 5, -3. So the hyperbola always encloses the foci. Here you can see the focus here is enclosed inside the hyperbola. The focus over here is enclosed also. So the general form of the hyperbola is this equation here, and A, where I got cut off by the computer here, A is 2. A is the distance from the center to the vertex. So you can see the center point here is going to be 1, -3. And that's just using your eye. You can see that this is midway between the two vertices. It's also midway between the two foci. And the coordinates of this point are 1, -3, which are h and k. So I plugged 1 in for h and -3 in for k, and I got there. Then A is this distance from the center point to the vertex, and you can see that that's 2. Okay, so that's where I got cut off. So we're going to use this formula that has to be memorized: a squared plus b squared equals c squared, because we want to create the box that in between the two arms of the hyperbola. So we have the vertical part of the box, and that's coming from A. A, as we said, is 2. So the vertical would be 2 here, and well, the coordinate is -1, obviously, and then here. So that we've got the vertical box. We need the horizontal piece of the box. For that, we use this equation. So A, you can see that A is from here to here, so that's 2. So it's 2 squared plus B squared, which we're trying to figure out. C is the distance from the center to the focus, and you can see that's 4. 1, 2, 3, 4. So that's going to be 4 squared. So B squared is going to be 16 minus 4, which is going to be 12. So now I can write I just have to change color, and I can write 12 here for B squared. And that equals 1. And if I want, so I've got the equation now here. If I want to, I can finish the box. Just have to change colors again. And so B it's not going to be convenient. B itself is going to be square root of 12, which would be 2 root 3. So I'm going to do that on my calculator, square root of 12, just so we can get a rough idea of where to put the box. That's roughly 3.5. So we're going to go up 3.5. 1, 2, 3.5. So the box is going to be here. and then down 3.5, 1, 2, 3.5. The box is used to find the asymptotes, and you just connect the corners of the box and draw the two asymptotes here. I'm not going to be able to make a very good box here, but I'll try my best to draw in the asymptotes. We're not being asked about the asymptotes in this problem, so technically this isn't required. But I just want to go through the whole thing so that you can appreciate what it might look like. And that's it. So that's the way to do it. Unfortunately, in my opinion, the best way to do this is by memorizing the formulas. And you need to know the formula for the hyperbola, of course. And you also need to know the formula relating A, B, and C. A being the horizontal distance, and B, this horizontal distance to the vertex, and then B being the distance to the C being the distance to the focus, and then you would use the box to draw in the asymptotes if you're asked. So that's the way to do this one. It's kind of messy, but it's doable. Just practice these, really. I think repetition is the key here. Okay, that's it for today. I hope that made your task a little bit easier. I'll see you next time. Bye-bye.